So in this example here, we're going to calculate the centroid of the following plate. Um, so this is an area. So what we're looking for here is our goal is to find x bar and y bar of the following area. So the first step we're going to do is we're going to break our total shape into parts. Alright, so to break this into parts, we can break it into three areas. We can break it into the small square on the left hand side of the part. We can break it into a second square, a rectangle on the left hand side of the part, and we can break it into a triangle on the right hand side of the plate. So the second thing we're going to do is we're going to determine x tilde and y tilde for each section. Right? So, and it really should be x tilde, y tilde, and the area for each section. So to do that, we're going to use our table. So we're going to have our area number, area number 1, area number 2, area number 3. Alright, we're going to have x tilde for that area, we're going to have y tilde for that area. Alright, we're going to have the total areas in feet squared. Alright, so for x tilde, what we need to do is we're going to have for our area number 1, it's going to be equal to, it's a 1 by 1 foot square, so halfway through 1 foot is a half of a foot, but area 1 is minus 2 feet away from the y-axis, so we have to include that minus 2 feet. So it's going to be equal to minus 2 feet minus an additional 0.5 feet, or it's going to be equal to minus 2.5 feet total. Alright, so that's the number that we're going to be interested in. Alright, here. Alright, so for y tilde, it's just a rectangle that's 2 feet by 3 feet. For area 1, it's just 1 foot tall, and it's 1 foot from the top of it. The square is 1 foot from the x-axis, so y tilde would just be equal to half of the height, or 0.5 feet. And then for the area, it would just be equal to 1 foot times 1 foot, which would just be equal to 1 foot squared. Right. For area 2, x tilde is equal to minus 1 foot. The total width of area 2 is 2 feet, so half of the width would be equal to 1 foot. And since the right-hand boundary of area 2 is on the y-axis, it would just be equal to minus 1 foot on the left. Alright, so area 2, the base of it sits on the x-axis, so y tilde would just be equal to half of the height. The total height of area 2 is 3 feet, so y tilde would be equal to 1.5 feet. And then the area would just be equal to 2 feet times 3 feet, or 6 feet squared. And then the area of the x and y component of a triangle, x tilde and y tilde for area 3, or the triangle. So triangles, their area, their centroids can be determined using this box here. So this box here gives you the information for a general triangle, where it gives you the 1/3 away from the base. The centroid will be located along that line. And then the only thing that this doesn't tell you is that for right triangles, so in the case of a right triangle, the centroid will be 1/3 along the base and 1/3 along the height of the triangle. All right. So from where the 90-degree angle is, you go 1/3 of the length, or the 1/3 of the base and the 1/3 of the height of that triangle. You will get to your centroid. All right. So that's for right triangles. All right. So if we go back at our right triangle here, so our x tilde in that case would just be equal to 1/3 of the base, which was equal to 3 feet. So just be equal to 1 foot. Similarly, y would be equal to 1/3 times the height, which is equal to 3 feet. So it would also be equal to 1 foot. And then the area would be equal to 1/2 the base times the height. So the base is 3 feet. The height is 3 feet. So our total area would be equal to 4.50 feet. Alright. So the last thing we need to do is we know that x bar is equal to sigma x tilde times the area divided by the total area, and we know that y bar is equal to the sum of y tilde times the area divided by the sum of the area. So we need to determine what the heck is x tilde a. We need to determine what is the sum of the total area, and we need to determine what the heck is y tilde a. So we can, if we sum up the area, we can determine the total area. So that would be equal to 1 plus 6 plus 4.5. So that would be equal to 11.50 feet squared. Then for the for x tilde times a, we have to do some multiplication. And then the same thing for y tilde times a, we have to do some multiplication. So if we do that, we would get for x tilde times a for area 1, we would get negative 2.5. These are all going to be in feet cubed. For y tilde times a, we would get 0.5. For area 2, we would get minus 6 feet cubed. And then for y tilde times a for area 2, we would get 9 feet cubed. And then for x tilde times a for area 3, we would get 4.50. And then for y tilde times a, we would get 4.50. Alright, so if we add these all up, x tilde times a, we would get minus 4.0, and then for y tilde times a, if we add those all up, we would get 14.0. So for x tilde times a, we would get minus 4.0 divided by 11.50. So this would be feet cubed divided by feet squared. So we would get minus 0.348 feet. And then our y bar would be equal to minus 14.0 feet cubed divided by 11.50 feet squared, and that would be equal to 1.22 feet. Alright, so if we looked at this on our original picture, our centroid here would be equal to right around this point here. Eyeballing it, and looking at our information, looking at our area, that's definitely a believable centroid. So I would say that our calculations were pretty close, are correct. So that's one way you can check to see if your centroid is correct. I would recommend plotting it on the original picture and make sure that it is in a location that would make some logical sense to you. Alright, so that concludes how you would calculate the area, the centroid for an area.